Okay, here is our example here to look at the application of the three equations of motion we have just looked at. Please write it somewhere there as your side work that the first equation we shall use is V equaling to U plus AT, and then S equaling to UT plus a half AT squared, and then this is 1, this is 2, and then don't forget lastly is V squared equaling to U squared plus 2AS. Is that okay? Those are basically the three equations we are going to use. And please don't forget that you should not, you should note that if the body initially was at rest or the body started from rest, initial velocity is equaling to 0. Is that okay? If the body started from rest, initial velocity is 0. And if the body finally came to rest, that means that the final speed at rest is 0. If a body is at rest, it has no speed. So if the body finally comes to rest, that means final velocity V is 0. Is that okay? And then next is that if the body is moving with a constant speed, steady speed, uniform velocity, maximum velocity, acceleration is taken to be 0. So we say you should note this one somewhere there, that if a body started from rest, U is initial velocity is 0. And then if the body finally came to rest, final velocity V is also. I'm trying to give you tips that will help you in each and every number that you will be doing. And then when we are saying that the body is moving with the uniform stroke steady, stroke constant, and then maximum velocity, acceleration will be equal to 0. Because they said that acceleration should be changed in velocity V minus U out of. In a scenario where the speed is uniform, that means that the body is not changing the speed. The initial speed is the same as the final. Therefore, if these are the same, that means if you subtract them, it will be 0 out of t. Therefore, it results in 0 acceleration. That is the scenario when the body is not changing the speed. That means that V is equaling to U. The initial is the same as the final because it is a constant value. It is a steady value. It is a uniform value or a maximum that the body cannot go beyond that, but will just remain there. So we say acceleration is 0 because there is no change in velocity. So having looked at that, it will now guide us to now check how we can solve this problem here. So they are saying that our question is saying here that a particle is projected away from the origin O with initial speed. Is that okay? That means that our initial speed U is 0.25 meters per second from the origin. And then they're saying the particle travels in a straight line and accelerates at E. Acceleration has been given to you as 1.5 meters per second squared. Is that okay? And now they're saying that find Roman 1 how far the particle is from O after 3 seconds. What does the word how far means? What is it meaning according to our variables here? How far? What is that? Is that velocity? Is that time? Or is that distance? Okay? So how far? That is a distance moved from the origin, isn't it? So if they say how far, they are trying to mean that find the distance. Don't forget, we have velocity, initial velocity, we have also acceleration, and then you have also been given time of 3 seconds. Now, which equation are you going to choose such that you can calculate the distance, because it's what they want, how far, you have time, you have this, you have that. So which equation among the three do you think you should choose which has all these given values, such that we can now find that? If you see properly, we are supposed to use equation 2, which is saying S equaling to ut plus a half at squared. Is that okay? Because I want S, I have T, I have A, I have U. Therefore, this equation qualifies for this part here. Is that okay? And then I can say that my S is equaling to U. What is my U? My U is 0.25 times T. T is 3. Clear? And then plus a half. What is my A? My A is 1.5. And now what is my T? Is 3 squared. Is that okay? And then you can go ahead and you pick your calculator and then press these values here. Is that okay? Please always practice pressing your calculator. The more you practice, the faster you become. Try again and again to press your calculator for practice. It will be embarrassing if you have a calculator and you can't even press some of the function. So I have here 0.25 times 3. Is that okay? That is giving you 0.75. I can work it step by step such that we don't leave anyone behind. That is 0.75. And then plus, you also press the other part. You say now 1.5. Okay? Times 3 squared, which is 9. You get that and then divide by 2 to get what is there. That is 6.75. Please, as I'm pressing, don't assume that that is very simple and we leave it. The heart of math paper 2 is all about calculator. The number of people have gotten a problem because of pressing a calculator. So be confident with it. And now if you add that, your S will now be equaling to, you add 0.75 and then you'll get 7.5. And we also said that please don't forget the unit. You forget the unit -1 on your answer. And then we shall now say, make a conclusion that therefore the distance covered after 3 seconds from the origin is 7.5 meters. Always you make that conclusion there for your final answer. And then let's meet in the next episode for the second part of our calculation. So, if we are now to continue with this one here, to solve this second part here, that means that we are supposed to say, for Roman 2, they are asking you the distance traveled by the particle in the first second. Is that okay? We are looking at in the first second. What does that mean? It shouldn't confuse you. Distance traveled by the particle in 4 seconds. It is different from saying distance covered by the particle in the first second. That means that if you're traveling from this point, maybe I can say this is the first second, the second second, the third one, and the first one. Our interest is this distance here in the first. If this was the first, second, third, and then this is the first one. We want exactly that distance, which is quite different from the distance covered in 4 seconds. That would call for you calculating all this one here. This one is the distance covered for 4 seconds, right away from the origin. Is that okay? But in the 4th second is from third, after reaching third, as you're going to the 4th second, what was just that distance? That is what this one always requires us to calculate. So, how do we calculate this distance here? I would suggest, or I'm telling you that to get the distance covered in the 4 seconds, you should first get the distance covered for 4 seconds, that is from here up to here, and then get the distance covered for 3 seconds, that is t equaling to 3. And when you get this distance for 4 seconds minus the distance for 3 seconds, you will remain with the distance in the force, not distance in 4 seconds. Please, I'm mentioning this again. Distance in the 4 second is different from distance in the 4. In the 4 second is right away from the origin. But in the 4th second is from the third to the fourth. Okay? So, having gotten that right, let's see now how we can now solve that. So, what is the distance covered in 4 seconds? Distance in 4 seconds, first of all. It will be S equaling to U. My U is 0.25 times 4. I'm substituting in this equation here. Plus a half times A. My A is 1.5. And then times T. We are saying now the time we are looking at should be a time of 4 seconds but squared. Okay? Said here we move slowly by slowly so that everyone gets it. That. So 0.25 times 4. That will probably give you what? That will give you 1. But you can confirm it by pressing. You never know. So 0.25 times 4. That is 1.0, and then plus, then you can say it is now 16 times 1.5, and then divide by 2. You'll get a 12. Is that okay? And then that will give you now 13 meters. Please, if now you feel like you can now use the calculator, even if now you use your weight, but for the beginning, please try so much pressing this so that you can get used to your calculator. And then what about distance in 3 seconds? Distance in 4 seconds, I can call it S4. And then distance in 3 seconds already has been calculated behind there as 7.5. The distance is 7.5 meters. So, having done that, we can now say the distance covered in 4 seconds is given by S4 minus S, or the distance for 4 seconds minus the distance for 3 seconds. When you subtract that, you'll exactly get the distance in the first one, from 3 seconds to the first one. So, we shall say that will be equaling to 13 minus 7.5, which is around 5.5. But you can still confirm it and press it and say 13 minus 7.5. And then you get your 5.5 meters. And then you make conclusion there. Therefore, the distance covered in the 4 seconds is therefore the distance covered in the 4 second is 5.5 meters. Is that okay? So that has been our example number 1. Let's now meet in the next example.